Last bit for the day is this. We're going to now be in section 7.5. We're going to get about halfway through in this class or this video if you're watching online. Section 7.5 talks about two things. And again, in the first section today, we talked about the two rules that we have for radicals, the product rule, quotient rule. We've been applying them nonstop ever since. And so 7.5 is no different. There's two things we're going to talk about here. We're going to talk about multiplying and dividing radical expressions. Now, the good news when we talk about dividing is there's almost no actual division in dividing radicals, but we are going to save that for next time. We're going to get to the first half of this section, talk about the multiplying. And so if you're comfortable with the product rule, multiplying what's under the radical by other stuff under and the stuff outside by outside, and simplifying, there's no new information here as well. In fact, I'm going to, again, link to something that I hope you came into this class already knowing. If I have this, 3 times 2x plus 7, way back, some lovely algebra teacher taught you to do what in order to simplify this? Distribute. Yes, distributive property. So you would have said, hey, this is cool. 3 times 2 is 6x. 3 times 7 is 21. And you would have been super happy. Well, same thing is here. So I've got square root of 5. And in parentheses, I've got 2 square root of 3 plus square root of 6. This is just a distributive property. And just the thing to keep repeating to yourself as you do this, you're applying the product rule, you multiply the things outside the radical by other outside stuff, the stuff under the radical by other stuff under. You don't cross over. So on this problem right here, I've got the square root of 5 times 2 square root of 3. But when I multiply those together, what's going to be outside the radical? 2. There's nothing else out here. And then what's going to be under the radical? Square root of 15. Great job. Plus, then I have square root of 5 times square root of 6. There's only ones outside the radical, so I don't have to write anything down. So then under the radical, what do I have? 30. Do either of those numbers simplify? Is there a perfect square factor of 15 or a perfect square factor of 30? Not in this one. No. 30 is 6 times 5 or 10 times 3. None of those have square roots. 15 is 5 times 3, so there's no square roots to be done here, so that one is completely finished. My purpose in asking that question is the only other thing that you would have to do here is if any of the radicals simplify, just what we were doing in the last section. So here's your first problem. Go ahead and simplify this. Go ahead and multiply the square root of 10 times 4 square root of 3 minus square root of 7. Almost the exact same problem, just different numbers. When I distribute the square root of 10, what's outside the radical when I multiply those two things together? 4, and then I have the square root of what? Okay. And then when I do the second term, I have minus, outside there's just a 1, and I have square root of 70. Anybody get anything different? Well, as long as it's not lying to me, that's good news. So try this one. I will give you a little hint in advance. One of the radicals after you multiply will simplify. You probably would have figured that out anyway, but just want to make this as palatable as possible. On this problem, when I multiply my first things together, so the 2 square root of 3 times the 5 square root of 2, what do I have outside the radical on this first term?
10.
Okay, 2 times 5 is 10, and then under the radical, I have 3 times 2 is 6. Wonderful. And then when I multiply the next pair of terms together, what's outside the radical here? Negative 14. And then under the radical, I have square root of 9. Okay. Well, 6 doesn't have a perfect square factor, but 9 is a perfect square. So let's finish this up. 10 squared is 6 minus, what's the square root of 9? 3 times 14 is 42. Anything we need to talk about here? If you understand this, then all the remaining problems are, you're great. Okay, we're just going to keep doing. Yeah, what's up? That's a beautiful question. So the question, in case you didn't hear it, is can I now do 10 minus 42? And I'm going to answer that as no. And why not? Why can I not combine those two things? This one has a square root of 6 on the back of it. This one does not. So they are completely different terms. Okay, so great question. I'm really glad we're processing it and getting that clear. Okay, that's a common mistake, and I want to get that out in the open. Okay, better? We good? Awesome. Awesome, awesome. Don't be afraid to ask your questions. Don't be afraid to ask that one again if you want to. It's all good. All right, so here's another one for you. Again, there's going to be one of the radicals here that will simplify. So this is 2 square root of 5 outside, and then I have 6 square root of 7 minus 2 square root of 3, and then finally plus 4 square root of 10. All right, my first terms, 2 square root of 5 and 6 square root of 7. What's outside the radical on that one? 12. And then underneath my radicals, 5 times 7 is square root of 35. 35 does not have a factor, it's a perfect square. That one is done. Now I've got 2 square root of 5 times negative 2 square root of 3. What's outside the radical on that one? Okay, 2 times negative 2 is negative 4. And then square root of 5, square root of 3 is square root of 15 again. We've seen 15, that does not simplify. The last one, 2 square root of 5 times 4 square root of 10. 2 times 4 is 8. What's under the radical on this one? 50. Now 50 is a number, we should recognize it because we've simplified this one a couple times already today. $50 has a perfect square factor of 25. Product rule of radicals says I can consider those two things by themselves, so I can take the square root of the 25. And what is the square root of 25? Okay, the square root of 25 is 5 times the 8 gives me. And nothing there is a like term, so we are good to go. I've got one more distributing property, and then we have one final thing that we're going to mop up for the day. Okay, so your time to ask questions is running out. Don't please, I beg you, don't leave here today with questions because you're going into the weekend. I'm hoping you're getting your homework done. You're not going to want to do homework over the break that we have, so get it done before the break. So here's the last distributing problem. So if we have 6 square root of x, and in parentheses, we have 3 square root of y plus 2 square root of x. Yes, sir. You would put them under the same radical. You would combine them. Yes. Good question. All right, so I'm going to multiply. So again, same sort of thing we've been doing. This time I just threw some variables in here just to make sure we're comfortable. So 6 times 3 is 18 outside the radical. And then just as was asked a moment ago, I've got x and y under the radical. So that's just x times y under the same radical. And then plus 6 times 2 is 12. And then x times x is x squared under that radical. So I do have just a touch of simplifying to do. And again, if you can take care of some of this stuff in your head as you get better at it, I totally get it. And in support of that, square root of x squared is x. And we're done with that. Yes? Which other squared x? Neither of these are squared. 12 is not under the radical, so I don't need to factor that. Is that what you're saying? 4 times 3? And it's right there. No, because it's not, if it was x squared times another x, I would, but x squared, the square root of x squared, what times itself gives me this thing right here? Well, that's x times x. So there's no x left over. There's only the 2, so I don't need a radical anymore. Okay, better? Awesome. All right, so last thing for today. So like I said, when you were doing your homework over the weekend, you can do all of section 7.3. We did that. You can do all of section 7.4. We did that. And in 7.5, do the problems that talk about multiplying. Anything that talks dividing, just wait. Unless you've done it before and you want to, but go ahead and wait and we will do that. So before we do something with radicals, just want to make this look familiar because it's something you've done before. Let's say that you have 2x plus 5 times, let's say 3x plus 1. What would we do here to multiply these things together? What is it? Yeah, the acronym that you were taught at some point in the past was FOIL. First, outers, inners, last. It's based on the distributive property. Okay, so foiling these, I'm just going to do this real quick because I'm assuming you've done 100 million of these in your life. Okay, and if you haven't and you're not good at it, let's talk. I've got some videos. If you need more of the perkster in your life, you can watch some of my foiling videos. Okay, so here goes. My first, 2x times 3x is 6x squared. My outers is plus 2x. My inners are 15x, and then my lasts are plus 5. And then we always know anytime we have those like terms, I'm going to add them up. So 2 and 15, 17x plus 5. My hope is that that is not a mysterious problem. Okay, I'm just trying to link together something that you've done in your algebra past. So here's my last problem for the day, and then we'll round out our time with you working some problems. So let's say we have these two things. Square root of 5 plus 3 times the square root of 6 minus 2. We're going to start with this problem. And again, if you've been following along with multiplying and making sure you don't multiply the stuff outside by other stuff outside and the stuff under by other stuff under, none of that changes. And there's nothing different here. Here goes. When I multiply my firsts, square root of 5 times square root of 6, what does that give me as a result? Perfect. Excellent job. Square root of 5 times negative square root of 2 is perfect. That 2 is outside the radical, so it's negative 2 square root of 5. And then 3 times square root of 6, what does that give me? Just what I said, right? 3 square root of 6, the 3 is outside the radical, the 6 is under. And then last but not least, the 3 and the negative 2 are both outside the radical, so that's negative 6. I don't have anything that's a like term. I don't have anything I can simplify. That problem is finished. So we have about 15 minutes left in our class time together. I know it goes so fast. I know you shed a tear every time it gets to be noon. I don't blame you. So here's a couple for you. Well, I've got like 5 of them that we probably have time to do. So here's your first one: 7 minus square root of 3, and then square root of 5 plus the square root of 2. Go ahead and multiply those two things together, please. All right, so I'm going to FOIL. If you get something different than me, please, let's talk about it. So my first 7 times square root of 5, the 7 is outside the radical, the 5 is under, so that stays 7 square root of 5. My outers, 7 times square root of 2, same thing. The 7 is outside, the 2 is under, so it stays 7 square root of 2. My inners, negative square root of 3 times square root of 5. Well, a negative times a positive is a negative, and these are both under the radical, so it's square root of 15. And then finally, square root of 3, square root of 2, negative times a positive again is a negative, and then they're both under the radical, so it's square root of 6. I have no like terms and nothing simplifies, so we're done. Anybody have a question? Anything at all, please? I don't want you to leave here and then get mad at me because you're confused. All right, next one. This is a great problem. You're gonna love this one. So we've got 4 square root of 2 plus the square root of 3, and then 5 minus the square root of 6. I'll give you a little word of advice. There will be 2 of the radicals that will simplify after you do your first step. All right, so I'm going to get started. Like usual, ask whatever questions you need to, because we're running out of time. We're just about to the end. So 4 square root of 2 times 5. So 4 times 5, that is 20 square root of 2. 4 and the 5 are both outside the radical. My outers, 4 square root of 2 times negative square root of 6. A positive 4 times a negative makes a negative 4. Square root of 2, square root of 6 is square root of 12. Anybody got anything different so far? The inners, square root of 3 times 5. This is the radical. This is outside the radical, so I've got 5 square root of 3. And then finally, square root of 3 times negative square root of 6. A positive times a negative is negative, and I've got square root of 18. Okay, that's great. You've done the first step well. There are 2 radicals that will simplify. What are the 2 numbers here that are going to simplify? Perfect. 12 is 4 times 3. We've simplified that number before. Again, you're going to see a lot of repeat numbers, so you'll get used to them. 18 is 9 times 2. Product rule of radicals says I can consider these two things separately. So the square root of 4, what's the square root of 4? 2 times the negative 4 out front makes negative 8, square root of 3. You comfortable with where that negative 8 came from? Don't be shy. Not hurting anybody but yourself if you're being shy and not asking your questions. Then over here, product rule of radicals says I can consider this square root of 9 by itself. Square root of 9 is 3. Oh, look at that. Out of nowhere, we got some like terms. So that makes this problem even more fun. Last step, I've got 20 square root of 2 minus 3 square root of 2 is 17. I told you you'd love this problem. And then negative 8 square root of 3 plus 5 square root of 3 is minus 3 square root of 3. And now we're finally at long last done. I cannot add these two. These are not like terms. Square root of 2, square root of 3, completely different things. And so we are done with that problem. All right, so this is going to be our last problem for the day. So if you have anything on your mind that we need to talk about, please don't take it with you. Let's talk about it. So it is this, square root of 6 plus square root of 2 times square root of 6 minus square root of 2. All right, so I'm going to get started. We'll meet at the end, make sure we all got the same thing. So my first, square root of 6, square root of 6, they're both under the radical, so square root of 36. My outers, square root of 6 times negative square root of 2, a positive times a negative is negative, and 6 times 2 is the square root of 12. The inners, positive times positive is positive, square root of 12. And then finally, my last, a positive square root of 2, negative square root of 2, positive times negative is negative, and then square root of 2 times square root of 2 is square root of 4. So if you did that, you did the foiling, great. So the rest of this is just, there's a couple things we can simplify. The first thing, straight away, what can I do? What do I see happens? Yeah, we can cancel. We've got some like terms, do we not? Negative square root of 12, positive square root of 12, those are the exact same thing. So I've got a negative one, I've got a positive one, goodbye, see you later. And then the square root of 36 is 6 minus the square root of 4 is 2, and 6 minus 2 ends up being 4. Before you pack up and go, I just want to mention something about this, because when we come back next time, this is exactly where we're going to pick up. Things like this become handy for us when we go to divide radicals, because in the division process, there's not a whole lot of division. These two things, notice we have the same two terms. We've got a square root of 6, a square root of 2, square root of 6, square root of 2. The only difference between these is one is positive, one's negative. When that is the case, when the only difference is the sign in the middle, these things are called conjugates. Now, you know, I don't quiz you on vocabulary, but I will be using that word when we come back next time, because we will use conjugates in order to do division of radicals. So just be aware. Other than that, I hope you have an amazing weekend. I will see you next week. Be well.